So if we think about some high-level goals that we want for deploying things, we want consistency, auditability, which means we want to use infrastructure as code. Any change we make is in code. We want automation, which means we want GitOps, right? We want to be able to just merge things to dev or to main, and those get rolled out automatically to our cluster. We want security, which means we don't want any exposed Kubernetes clusters. Literally just this morning, there was a pretty bad vulnerability on an ingress controller, Nginx. So obviously exposed control plane endpoints are not a good thing. So we want a way to deploy, to use GitOps and to use automation, but not have our control plane exposed to the internet or even at all. We want automatic reconciliation to prevent drift. And Flux and Crossplane are two tools that you can use to attain this. Don't worry about how complicated this is. This is just for orientation of kind of where we are in the platform engineering world. At the top, we have kind of our developer control plane, our source code, our IDEs. In the middle, we have Kubernetes, the Kubernetes control plane, and we're kind of sitting right here, Flux and Crossplane. On the right, we have all the resources that we're creating, right? And then we have our monitoring, security, but we're sitting kind of in the middle of everything. And we're going to start with Flux. And Flux is quite simple. All it does is it synchronizes Git source repositories with a Kubernetes cluster, and it reconciles the declarative Git definition of what resources you want, and it deploys those into Kubernetes. It's a CNCF graduated project, so it's very grown up. It actually graduated, moved to adopt alongside Helm, so it's a grown-up project. It supports multi-tenancy, multi-everything. You can have multiple Git resources. You can even provision other clusters from Flux, so it's multi-tenant and multi-everything. It, of course, has good support for lots of UIs. Kind of one well-known standalone one is Capacitor, but there's plugins for Weave, for Backstage, for Headlamp, and there's also like VS Code integration as a GUI. So you can see what Flux is doing quite easily. The way that it works, so when you bootstrap Flux into your cluster, you install it in your Kubernetes cluster, and it creates a source controller. That source controller can talk to Docker repositories, to Git repositories, even to S3 compatible, just places where you're storing your artifacts, right? The source controller pulls those, and it's a common interface for artifacts. It does all the validation, all the authentication. It can do source authenticity with PGP, so to guarantee that, okay, I am talking to my GitLab instance. It can fetch resources on demand, for example, for Helm, and it can fetch them on a schedule. And then detect the source changes, package those properly the way that you specify it, Thoor, YAML, and then make those resources available in the cluster for the downstream controllers to then go and deploy things. The good thing about this is, like I said, on a schedule. The fact is, you can now completely shut down your control plane because Flux, once it's installed, can sit inside your cluster and basically pull changes and pull them in. And that way, Flux allows you to shut down your control plane, have a completely private control plane, and still manage your cluster very effectively. The second part is then your customized controller. So out of your Git repository, you have customized YAMLs, and the customized controller is then responsible for reconciliation. So it then says, okay, we need this resource, I'll go create it for you. Additionally, for example, Helm, which is another well-known way of deploying things in Kubernetes, Helm can talk to the source controller to fetch its definitions and then deploy things into the cluster as well. The notification controller does what it says on the tin, allows you to notify out to Slack, whatever you need. So that's kind of a very quick, high-level view of what Flux does. It allows us, like I said, it gives us the infrastructure as code. It gives us the reconciliation that we need. It gives us the security we need because we don't expose our control plane anymore. And it takes care of deploying the resources that we need inside of the cluster. The next part of that, of course, is, well, we have some resources that live outside of the cluster, right? And that's where Crossplane comes into play. With Crossplane, you'll see a lot of similarities to, for example, Terraform. Basically what it does is it talks to APIs to deploy resources. And if it has an API, Crossplane can talk to it. There's even the creator of Crossplane created a Domino's Pizza API provider. So you can use infrastructure as code to order pizza if you want, using Crossplane. And the point of this is if you have an S3 bucket that you need for some Kubernetes service, you can, of course, define it outside of. You can define it with Terraform and then pass it in. But if you want to manage it together with your Kubernetes service, you can now use Kubernetes specification and make it live with your service and still deploy those AWS, those resources that are outside of Kubernetes, whether it's Route 53 or S3 or a database or whatever. You can basically take the Kubernetes control plane and extend it to be a universal control plane. And that brings all of your non-Kubernetes resources into the same definition files as your Kubernetes resources. So those are the two components that we're going to look at in the demo. And that's just a very superficial, quick introduction. So with that, I will hand off to George. Live demos, always fun. Waiting.
It's better now.
You're live. I detected it. It's just not.
Yeah.
There you go.
Hello. First of all, I'm George. I'm a software cloud engineer in Copy the last 3.5 years. So I will try to introduce these two Kubernetes native tools, Flux and Crossplane, with some pretty basic examples that we can follow them. So let me. I also keep some notes here, so I will try to share a lot. I just quick always mention a little bit some notes here when we need them. So again, Flux, as Jan mentioned, is a tool for keeping in sync resources of configuration with source of configuration, like Git repositories. I mean, with simple words, let's assume we have an application. Let's say we have a service and we would like to deploy that to Kubernetes. But traditionally, we can use even kubectl command to communicate directly with the cluster, and we can deploy by applying, let's say, deployments or services or whatever manifests over the Kubernetes. But what we will try to showcase right now is how we will be able to deploy an application, let's say microservice, as I will show you, from a Git repository, but not by ourselves, but leaving Flux actually to go to Git repository, take the deployments we have inside this Git repository, and actually deploy our application to a Kubernetes namespace. So for that, I just want to say here that I will refer to 3 different repositories. One is the workload account, one is the service, and one is the Flux config. Let me say a little bit for each of them what it means. The Kubernetes cluster, it has to exist, right? So we start all this discussion right now assuming that the Kubernetes cluster itself and the VPC and the IAM roles and whatever you need as a base infrastructure on your AWS account already exists. So usually today, I mean, there are many techniques, of course, but usually the mainstream today is Terraform. And Cobit has invested a lot of time and energy to modularize really properly a lot of modules. And one of them is the EKS, as you see here. So there is a module with a specific version. As you see here, we have our own kind of registry with all the modules with a specific version. So this demo assumes that the EKS cluster is already there provisioned, together with the two native tools that Jan mentioned before, the Flux and the Crossplane. So speaking about Flux, speak about a Kubernetes native tool that actually checks a repository and tries to deploy things from the repository to the Kubernetes. I mean, the Flux is not something magic. We have to install it first in the Kubernetes, together with a Crossplane, like any other operator, let's say, in the Kubernetes itself. This is why the Flux and the Crossplane, they are already installed in the EKS cluster. I have here an account. This is just a demo for this specific demo in Zurich region, where you see the Kubernetes cluster, and as I mentioned, the workload account, everything has been provisioned with Terraform. I'm mentioning that again because I would like all of us to understand what is then the role of Crossplane at the end of the day. Yeah? If we can provision cloud resources with Terraform, why Crossplane is here on the table and why we need it or not. So all the basic infrastructure with Crossplane and Flex has been provisioned already with Terraform. Let's go to the next repository. As Jan mentioned, let's go here back to these repositories. As Jan mentioned before, there is this Flux config. So actually, when Flux is getting installed to Kubernetes, it has to be registered, let's say, with some sources. Today, we will integrate Flux with a Git repository. So the source of truth, it will be in a Git repository, and the Flux actually, it's already speaking to this GitLab repository. But how it speaks, I mean, it's not magic. When you register actually Flux initially with the module I mentioned before or by yourself, when you give actually a GitLab repository, you have also to give a token. You have to take a token from your GitLab environment and to give the repository with the token. And the token, of course, it should have the proper permissions for Flux to go to your repository and to be able to read or even to write. Today, we will read only. We will make just some pooling, but just have in mind that Flux, practically, if it has the right permissions, it can even write back to the Git repository for if this is required. So just imagine a Flux is just a citizen of Kubernetes, and it has to have access to this Git repository. So this is the second repository, and the third one, it's like it's the service. It's just a simple service that I would like to deploy, let's say, to this repository. So it's to this Kubernetes. So it's a Node.js service. It's doing nothing. It just expose an interface, an API interface with a get operation on the hello, and we get a message hello from Copit. As you see here, there is a Docker file that Dockerizes actually this application, and I will show you afterwards a little bit also a pipeline that we interconnect all these things. But the idea is the following, to connect it once more. The idea is that we have 3 repositories, right? Let's forget the first. I just mentioned the Terraform. I just mentioned that I make it clear that actually somehow all the initial resources should be there. But let's forget, let's park the Terraform for a minute. We have the Flux repository already registered with EKS, and we have one repository that keeps the microservice. So let's go to the Flux config here. So as you see here, there are a lot of folders. Let's focus specifically to this workload service. As you see here on this repository, I just have a deployment. This is a native Kubernetes deployment manifest. And here, as you see, there is, yes? Yeah, sure.
Yes.
So there is a native deployment resource on this repository, and you can see here that actually what we try to do with this deployment, we try to deploy this specific image to the Kubernetes. So this image, as you see here, it's coming from an ECR registry. So let's go now, and as Flux is already registered, that means that it can read this deployment config manifest right now, and it can already deploy the application to the Kubernetes cluster. So if I go right now to the Kubernetes itself, so all these things are getting deployed to the default namespace. So let's make a, yeah. Yes, as you see here, the workload service, it has been deployed with one replica inside the Kubernetes. And how this has happened is because Flux was able to read this specific configuration, this specific manifest on the Flux config, and it took the image and it deployed that to the application. But let's make sure right now that this is really, really interconnected. So what I will do as a first step is I will say I don't want one replica for my service. I would like two replicas. So I don't want only one pod to run inside my Kubernetes for this service. I would like to have two pods, right? So the only thing I will do is inside the Flux config repository. So let's go to this Flux config repository. I have here locally, I just change the replicas from 1 to 2. Okay? Nothing more, nothing less. I'm not interacting at all with the Kubernetes cluster. The only thing I will do, I will make a commit to this Flux config repository. So let's make this change. Let's make this commit. And then I will show you how this is. So I made a commit. Let's go to see actually this commit to the repository. So let's refresh actually the page. As you see, the replicas here are 2. And then let me introduce you something more. So the Flux CD doesn't come by default with a UI interface, but there is this capacitor UI. It's an open source tool, but not implemented by the same team that provides the Flux CD operation. And here what we see, we see here two deployments. The first one is the deployment that we just saw before on the repository, and here we see already that 2 pods are running. If we click here, actually the Flux customization, I mean, we here with this click the deployment, the workload service deployment, we see here how it is associated actually with the repository itself. So we see the customization resource associated with the deployment. But let's not focus on the UI. So here you see that actually before a minute there was a commit here. If I click this commit, actually I'm just getting redirected to the Git repository. So actually, if you see already visualized in the UI, the Flux already realized that I changed the replicas from 1 to 2 and tries to apply these changes to the Kubernetes. And the result of that, it's like, as you see here, there are 2 running pods for the workload service. And of course, if I go back to the Kubernetes cluster to check this, let's make now get pods. You see there are 2 pods running. One just came before some seconds. So just by doing a change on the repository, the Flux realized that and deployed back to the to Kubernetes. Let's revert back the chains, just to see also the opposite and follow that a little bit closer right now. Okay, let's follow closely now the change. You see, it was really, really fast actually. I didn't even catch it because there is an internal polling inside, and I think it's 1 minute we configure it, but it's pretty fast. So if I click right now the commit, you see it already understood the commit, so it changed the replicas. And of course, if I go back to the repository itself, it will show me now one pod. Okay, good. All good till now. But the deployment, as we saw before, actually it tries to deploy an image, right? There is an image here that we try to deploy in Kubernetes. But usually, I mean, the images, they are produced by our code bases. So usually in a proper microservice environment, we might have a lot of microservices around that they have to be deployed. So this is why I mentioned before, we have also another repository where actually this specific image is sitting. So to see a little bit the full flow, what I will try now to demo you is, and let's follow then a little bit this pipeline. I will make some changes. Here we see that this interface says hello from cockpit, right? Let's make some changes to the code. Let's go to the service. And let's change, let's say here, hello from the cockpit team. Let's add the team because we are a lot today here. Okay, let's make this commit. I'm not committing to the Flux config repository. I'm committing to my microservice repository right now. I will present you how all these are interconnected, but I didn't commit to Flux, so Flux doesn't yet know about this commit. But I'm pushing this change right now. Good. So let's go to the repository here. Let's go to the service. And let's check a little bit what is happening. So actually this commit, it triggered a pipeline execution, right, on the microservice repository. So let's follow a little bit this pipeline. It's pretty basic, and of course it doesn't follow any advanced. We did it just really simple that we follow that today. So as you see, the goal of this pipeline is to build our Docker image, to push it to the ECR registry that it's sitting to AWS. So if I go to AWS here, if I go to ECR, you will see that there is an ECR registry that keeps all these images that we built from the microservice. And after it builds actually the image, let's follow that. So I will not also speak today about the OIDC proper authentication to the AWS environment, but as you see here, before the execution of the pipeline, we properly create a secure session with AWS in order to be able to push something to the ECR registry. But I will go directly here. So as you see here, what we do, we build the image, we tag it, and we push it to the registry that I showed you before. But how Flux will know that we do have a new image that it has to be deployed? How Flux will know that we do have a new version? So again, this is the main principle, and there are a lot of ways to achieve it technically. But here, if you see, what we do is the following. We actually clone on this specific pipeline the config repository of Flux, and we go to the specific deployment file that we discussed before. And what we do, we try to update. There are many techniques of updating, but here we just do for simplicity an inline update actually of the deployment. So we say, wherever you see workload service on this deployment file, change the image version to the specific commit, and then commit it, please. So actually, we do a change to the Flux repository, and we commit back this change to the Flux repository. So if I go right now to the Flux config, I will see here a commit. You see, 1 minute ago, this is the Flux config. One commit came, and the commit, what it's doing, it's changing the image. This is the commit hash key, actually, appended here. And now Flux, it has to see this change because it's a change on the Flux repository, and it will be able to deploy that. Let's see that actually. Let's go back to the UI. So here, let's follow this. You see already, because as we said before, it's too fast, already detected the changes. So if I follow the commit, it went me right now to the change I did on the image. And in this way, it understood that there is a new version of the image, and it deployed that to the Kubernetes cluster. And in order to prove that, I'm not exposing anything publicly. I just create port forwarding for now for both, for simplicity. But now, if I go here to the application, if I refresh, the Kobit team is here. Again, one more time. We did a change to the service repository. We actually updated the Flux repository that there is a new version in an automated way. We didn't deal at all with the Kubernetes cluster, and the Flux even went to the ECR because it has a proper permissions. It took the new and deployed that back to the Kubernetes. Okay, just to speed up, and I'm closing. Now, what about the Crossplane? What we discussed right now, it was about make a proper deployment of an application to Kubernetes using native Kubernetes manifest, right? We just use a deployment and the service account. The Crossplane, it helps us using the same GitOps approach, the same Flux repository, let's name it, the same GitOps infrastructure we have. It helps us to use the same GitOps approach in order to provision cloud resources to the AWS account specifically. I mean, as Jan said, there are a lot of providers, but one of them is the AWS provider. So, as Jan said, I mean, and then why to do with Crossplane and not with Terraform? Let's assume right now the microservice team wants an SQS, it wants a queue, right? An AWS queue. How it will provision it? How it will provision it? Theoretically, it should go to the platform engineering team that is responsible for the Terraform resources, right? And it should say, hey, Jan, you are responsible for Terraform. Please, we need an SQS queue. Please deploy that for us. Or maybe the microservice team has the same access to the Terraform resources, and it can change the Terraform resources from an SQS queue. But just imagine, again, this is one of the principles that I mean, myself, I see that a little bit applied more and more, because again, it's another layer of providing cloud resources, provisioning cloud resources, and that many people may assume that, yes, but this is the same like Terraform. It's another level of complexity. Yes, true, but what about if we would like to give the power to the microservice team to provision, with the proper permissions always, to provision the resources they need by themselves? What if the full life cycle of an application, including the cloud resources, are totally managed by themselves? This is what Crossplane is trying to resolve. And again, in Terraform, the other difference is also that Crossplane actually is, as Jan mentioned, is reconciling always by itself. It's a GitOps, so it just checks the state and uploads it every minute, updates the state to be synced. Terraform, you have to apply by yourself. You have to make an apply by yourself to apply new resources. Here, by committing to Git, a new resource will be deployed. But let's see that in action, and I'm closing. So I'm back to the service repository, and here I just have one. Let me open it. I have just one Crossplane folder. Now you will tell me, George, why you have the Crossplane cloud resource, you have it in the repository. It doesn't matter. You can put the Crossplane resources or even your deployment resources in whatever repositories. You will see teams that they have one Git repository for the Crossplane resources, one for the Flux config. You will see teams that they merge everything together. They have one repository with everything. It doesn't matter because the Flux repository, it can just be updated and it can take sources from everywhere. You can connect the Flux repository with different sources, or you can even connect the Flux initially with different sources. This is why I just put it here to make it a little bit more interesting. But in my service application, I say here, create for me please a queue. This is an SQS queue in AWS with this name in the Zurich region and using this provider. So as you see here, this is not native Kubernetes manifest. And this is what Jan said before. This is the custom resource definition that Crossplane understands and transforms afterwards to a native AWS SQS resource. So the Crossplane is totally based on such custom resource definitions. So I will just commit these chains to prove that I don't fake it. I will go right now to SQS quickly on Zurich region. I will check here if there are any SQS queues, and you see there is no any SQS queue, right? But how then Flux is knowing right now the change I did to my repository? So this is what I tried to explain before. If I go back to Flux config, if I go here, one was the workload service, but there is one more folder here. In this folder, I say to Flux, look, I have a controller, customization, because everything is on customization resources. I say, look, try to use as a source also the Git repository with name workload service. And if I go one level up, here there is another YAML where we register, here we can register different Git repositories. So as you see here, I just register my Git repository also. This is on top of what we did before. This is what I try to explain. We can even keep resources on the same, but you can say also Flux, look, I have one more repository that you would like to check, right? So I just registered the repository, and here the workload service Flux knows about this repository. And I say, look, the path /crossplane. It is the path where in the other repository, we just push these chains here. So let's go back to see the chains. So as you see here, this already is doing changes. But here, let's go to customization, because this should be a customization change. Yes. Let's follow. You see here, there is a customization resource that it's also following, and this is the workload service Crossplane. If I follow this commit right now, you see this commit is the commit I just did where I pushed the Crossplane resource. And what is this doing? Because Crossplane is installed on the Kubernetes cluster, as we saw before, this now from Flux is getting propagated to our Kubernetes cluster, and then the Crossplane operator understands actually this custom resource definition, translates it to SQS, and now if I go back here, if I refresh, I have my SQS queue, a totally native cloud resource provisioned by Flux from my own repository. Again, guys, maybe it's a little bit overcomplicated, but we try to make as simple as possible, and that you get the feeling of the whole journey, and just scale it to. I have seen myself with Crossplane, full infrastructure, because I saw a team that they had the principle that like the platform engineering is fully isolated from the microservices. So the microservices teams, they were provisioning everything by themselves. They had, for example, you see, this is a Crossplane RDS resource. So RDS with roles, with service accounts, with Kafka clusters, with everything, it was just driven by Crossplane, and actually the platform engineering team was defining the boundaries. So they were defining what each microservice team would do.